Acid resisting cement. Acid resisting cement is a special type of cement which is manufactured taking into consideration its capability of resisting corrosion by acids in the post hardening stage. Very specialized combination of ingredients are used in the manufacture of acid resisting cements. Acid resisting cement is used in concrete and reinforced concrete structures to be exposed to corrosive action of mineral and organic acids. The cement consists of pure quartz sand, uh, SiO2, and sodium fluorosilicate, Na2SiF6. They are taken in definite proportions and then grounded together to a great fineness. The two constituents of the cement can be ground individually, then the two powders may be mixed intimately. This cement uses an aqueous solution of water soda glass, that is sodium silicate, as a mixing liquid. Concrete with such a cement as a binder turns in air into a strong stone material. This cement is not stable to phosphoric acid, hydrofluoric acid, and hydrofluorosilicic acid. It should contain not less than 92% of SiO2. The quality of this acid resisting cement is assessed by its 30 days tensile strength, amounting to not less than 20 kg per square centimeter, and its relative percentage acid resistance 93%. The next type of cement is the super sulfate cement. This cement is manufactured, that is super sulfate cement is manufactured by fusing together blast furnace slag, a small amount of lime, but large quantities of gypsum. This cement is exceptionally resistant to chemical corrosion and is used especially in making highways. Superphosphate cement is also known as slag sulfate cement. These cements are available in two forms. The first form is thus known as slag gypsum cement, and it is manufactured by grinding together granulated blast furnace slag 75 to 85% of gypsum, that is calcium sulfate dihydrate CaSO4 2H2O, or anhydride 15 to 20%, and Portland cement clinker up to 5%, or we can also use lime, that is calcium oxide, up to 2%. The second form is known as the slag cement without clinker, produced by grinding together granulated blast furnace slag and hardening accelerators, that is 5 to 8% of burned or calcinated dolomite, and 5 to 8% of anhydrite or calcium sulfate hemihydrite. This special type of cement exhibits greater resistance to the action of sulfate waters, and it is distinguished by a considerably lesser heat of hydration, that is heat generated by setting and hardening of cement, compared to Portland cement. Uh, Super sulfate cement is manufactured by grinding together uh, the above constituent materials. Uh, it should be noted that the burning temperature of dolomite is used as an alkaline exciter of slags. For a basic slag, temperature range is 800 to 900 degrees centigrade, causing complete decomposition of magnesium carbonate and partial decomposition of calcium carbonate. For acid slag, temperature ranges in between 1000 to 1100 degrees centigrade, resulting in complete decomposition of magnesium carbonate as well as calcium carbonate. According to compressive strength, two brands of slag sulfate cements are available, brand 300 and brand 400, which are present in the market. The setting time and the fineness of grinding of slag sulfate cements are similar to those of Portland cement, while kept in storage or in preparing mixes. Such mixing drastically deteriorates the properties of slag sulfate cement. Slag sulfate cement should not be used as a binder in concretes to be subjected to weathering in service. That is, which are subjected to heating or abrupt cooling, freezing, and thawing. Because concrete with a slag sulfate cement binder decays gradually. This is why these cements find use in concrete and reinforced concrete structures and mortars used for underground or underwater surface. White cement. The color of the ordinary Portland cement is grayish black due to the presence of iron oxide present as one of the constituents. If iron oxide can be avoided or removed by suitable selection of raw materials, it is even possible to get white cement. Hence, if low iron feldspar, limestone, and gypsum are fused together at 900 degrees centigrade and then they are leached with water, the fusion of the leached product at 1400 degrees centigrade gives white cement. White cement is mainly used for decorative constructions. White cements and white cement based colored cements of light hues are produced from a clinker burned from a raw mix containing a minimum amount of iron oxides. There should be minimum content of the mineral C4AF tetracalcium aluminoferrite in the clinker. The whiteness of the concrete is predetermined by its bilite, that is C2S constituent, which impairs cement quality. Colored cement. Colored cement can be obtained by mixing white or grey Portland cement with suitable colored pigments. These pigments must have fine state of subdivision, suitable color and chemical composition, not destroyed by the components of the cement. For getting blue, green, black, and red cements, the pigments that are respectively added are cobalt blue or ultramarine, chromium oxide, carbon black, and iron oxide. Pigments of mineral as well as organic origin are available. The multitude of pigments added to Portland cement in the manufacturing of colored cements differ in composition and quality. Depending on the color design, the pigments are added to the cement. Mummy, that is Prussian red, minium, chromium oxide, ultramarine blue, phthalocyanine, ultramarine green. The latter has a high light stability and resistance to weathering, alkali resistance, and acid resistance. The whiteness of cement is assessed using barium sulfate as a reference color. Its reflection factor is not less than 0.93. Whiteness is determined by the luminescence factor by means of a photometer. In distinction to mineral pigments, for example chromium oxide, of which up to 7% is added into Portland cement, organic pigments are used in small amounts from 0.05% to 0.2% of the mass of Portland cement. Colored cements are classed as hydraulic binder since the main constituent is Portland cement. Construction makes wide use of cements of different colors and hues. They are used in the fabrication of mineral paints, mortars, and concretes of different strength and resistance to frost. According to strength, colored cements are available in three brands: 300, 400, and 500 kg per square centimeter. Industry makes available the following colored cements: black, blue, green, dark, pink colored, orange colored, yellow, goldfish yellow, bright yellow, and white. Pigments and the raw pigment material used must not impair the construction engineering properties of the colored cements. That is why pigments and the raw materials are checked for light stability and alkali resistance. These coloring agents should not reduce the strength, frost resistance, water permeability, resistance to weathering, and other properties of mortars and concretes. It should not impair the paint applied on the surface of the colored cements. The paint applied on the surface of structures in which colored cements are used must not fade, and architectural finish must retain its coloring, offering proper resistance to weathering. The color of the aggregates intended for colored cement, mortars, and concretes must suit the cement binder. Colored cements are tested by physico-mechanical properties. Colored cements are packed in multi-layer paper bags.